We're discussing about electricity, class 10, chapter 11. Let us see what is electric current and what is electric circuit. The charges flowing in a conductor is called as electric current. For this electric current to flow, there should be a continuous and closed path. This is called as electric circuit. We usually use switch as the conductor link between the battery and the gate. In case if the circuit is broken, the current stops flowing. This is a simple circuit where one battery is connected to the bulb through a switch, and the switch is on. The charges from this battery will flow from one direction to another direction through the conductor, and the bulb will glow. The switch makes the conducting link between the battery and the bulb and creates a closed and continuous path. This circuit is called open circuit because the switch is off. That's why there is a breakage is created there. So from this battery, no charges cannot flow through this conductor. That's why it's called open circuit. This circuit is called a closed circuit because the switch is on. There is a closed path between the battery and the bulb. So easily the charges can move from the battery to this lamp. We can express the electric current by using the amount of charge flowing through a particular area in unit time. Or simply we can say it as rate of flow of electric charges. We always take the direction of electric current is opposite to that of the direction of electrons. Just consider an electric charge Q is flowing through a cross section of conductor in a particular time t. Then the current we can find out by using this equation is equal to Q divided by T. A SI unit of electric charge is called Coulomb. We usually use ammeters to measure the electric current. It is always connected in series because in series connection the electric current is same. The electric current is expressed in amperes, and 1 ampere is equal to 1 coulomb divided by 1 second. That means to flow 1 coulomb of electric charges in 1 second, we usually use 1 ampere of electric current. Let us discuss about electric potential and potential difference. As we all know about the electric current, that's a flow of charges within a particular time period. To flowing these charges from one direction to another direction, there should be a condition. That's the difference of electric pressure. That means the positive and negative charges should be there, and there should be a difference. This is simply called as potential difference. Potential difference usually produced by these batteries. The chemical action within this battery, they produce this electric pressure difference, and that's why the potential difference. This is a diagram where battery is connected to the bulb through a metallic conductor, and because of the chemical reaction inside this battery, some electric pressure difference created. That's why it created a potential difference. When the battery is connected to a conducting circuit, the potential difference sets the charges in motion and thus produces the electric current. In order to maintain the electric current within the circuit, the battery has to expend all its chemical energy within it. Potential difference between 2 points in an electric circuit is the work done to move a unit charge from one point to another point. Potential difference V is equal to W by Q. SI unit of potential difference is volt. 1 volt is the potential difference between 2 points in a conductor when 1 joule of work done to move 1 coulomb of charge from one point to another point. 1 volt is equal to 1 joule divided by 1 coulomb. Potential difference we can find out by using the voltmeter. We always connect voltmeter parallel across the points where the potential difference is measured because in parallel connection all the devices have the same potential difference. The next topic is very important in electricity, that's Ohm's law. Ohm's law means it's simply the potential difference is directly proportional to the current provided the temperature is constant. V is equal to R into I. R is the resistance of a material where the temperature is constant. Resistance is the property of a conductor as its name denotes that resists the flow of charges through it. By Ohm's law, resistance is equal to voltage divided by current and its SI unit is ohm. Current-free resistor is inversely proportional to the resistance. The materials having low resistance is called good conductors and having higher resistance is called poor conductor or insulators. Factors on which the resistance of a conductor depends on its length, its area of cross-section and the nature of its material. Resistance is directly proportional to the length of that material and inversely proportional to the area of cross-section of that material. So R is equal to rho into L by A, where rho is the constant of proportionality of that material, that is called as resistivity of that material, and its SI unit is ohm meter, and it is the characteristic property of that material. The conductors have a low resistivity and the insulators have high resistivity. Then both the resistance and the resistivity of a material vary with temperature. Let us consider resistance of a system of resistors. There are two methods to join the resistors. One is parallel connection and the second one is series connection. First consider series connection. The schematic diagram of two resistors connected in series. This is a circuit diagram of resistors connected in series. Let us find out the total resistance of the circuit. In this circuit, the total potential difference is V, that is equal to the sum of potential difference across all these resistors, that is a V1, V2 and a V3. That the potential difference is equal to the sum of potential difference across the individual resistors. So V is equal to V1 plus V2 plus V3. Let I be the total current and R be the total resistance. Then apply the Ohm's law to the three resistors separately. We got the equation for V1, V2 and V3. Then substitute these values into the main equation and then we got the final answer. That's the total resistance is equal to the sum of all the resistance connected in series. Next one is parallel connection. This is a schematic diagram of two resistors connected in parallel. This is a circuit diagram of resistors connected in parallel. Let's find out the total resistance of this parallel connection. In each branch, the current is different, and so the total current is equal to the sum of all the currents in each branch. So the total current I is equal to I1 plus I2 plus I3. Let R is the total resistance and V is the total potential difference. Then by using the Ohm's law I is equal to V by R, we can apply this equation to the all the branches I1, I2 and I3. By substituting this equation into the main equation, we got the total resistance 1 divided by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Some drawbacks of the series connection in real life are: it is obviously impractical to connect two or more components in series because different components need different values of current. When one component fails, the circuit is broken and none of the components will work. Now let us consider about heating effect of electric current. When we use battery as a source, a part of the source energy is used in the form of first maintaining the current may be consumed into useful work, and the second part, the rest of the source energy expended in heat, and it raises the temperature of the gadget. If the electric circuit is purely resistive in character, all the source energy in the battery get dissipated in the form of heat. This heat up of the circuit is called as heating effect of electric current. Consider the current I is flowing through a resistor with resistance R and potential difference V. Then the work done to move a charge Q from one point to another point at time t is equal to V into Q. Power input to the circuit by the source is work done divided by T. Work done we already know that's V into Q. So we got the equation V into Q divided by T. From this equation we learned that Q divided by T, that's the rate of flow of electric charge, that is called as electric current. We can substitute Q divided by T as I. So we got P is equal to V into I. Energy supplied to the circuit by the source in time t is equal to power into time. We already know P is equal to Vi, so we got energy is equal to Vi into T. This energy is dissipated in the resistor as heat. So for a steady current, the heat produced is equal to the energy supplied. So H is equal to Vi into T. By applying the Ohm's law, we got the heat equation as I square into RT. This is known as Joule's law of heating. Heat produced in a resistor is directly proportional to square of the current through a resistor and resistance and time for which the current flows through the resistor. Let us consider the electric power. Electric power means the rate at which electric energy is dissipated in an electric circuit. Power is equal to voltage into current. By applying the Ohm's law, we got two equations. Power is equal to I square into R and V square divided by R. SI unit of power is watt. Some of the practical applications of heating effect of electric currents are electric laundry iron, toaster, oven, electric kettles, and these are the familiar devices based on Joule's heating. Electric heating also used to produce light, as in the electric bulbs. In the electric bulbs, the filament get very hot and emit lights. Usually we use this tungsten as the filament and it has high melting point. Fuse used in electric circuit, it protects the circuit and appliances by stopping the flow of any unduly high electric current.